Hey class, this is the video for lesson 84. Lesson 84 goes over some concepts that you use when you solve algebraic problems. This is pretty much a review. They're reviewing it because they want to give you some properties. That is, in the lower left here, you see properties of equality. They're reviewing this for you. These are things we've already done, these concepts, but I'm going to review them. They shouldn't look too foreign for you, and I'll work a few problems for you. All right, so they start by talking about formats for the addition rule. So if you look over here with where the purple and blue writing is, we start with the algebra problem, 2x minus 3 equals 5. This is a standard solve for x algebra problem. Previously, I think they've called these two-step problems because we've done a lot of getting x by itself on the left where we divide both sides, or sometimes we multiply by the reciprocal fraction. But they had a chapter where they called these two-step problems because here you would need to get rid of a constant. You'd have to get rid of the 3. Get rid of is sort of a slang, okay? We don't get rid of it. Technically, we add 3 to both sides. So that's kind of a slang when I say get rid of it. But in our process toward getting x by itself on the left, the first step is to add 3. So that when we add 3, then it disappears from that side. And then we would have to divide both sides by 2, because then we would have x with this coefficient of 2, and then we'd have to divide by 2, and then x would be, quote, by itself. So that was called a two-step problem. All right. So when we do these two-step problems, we start with our constant here. A constant is just, in an algebra problem, a constant is a number that isn't attached to a variable. So this 3 here is a constant, 5 is a constant. 2, on the other hand, is called a coefficient because it's in front of a variable. So when we have a number in front of a variable like that, or multiplied by a variable, that's called a coefficient. So our first step here would be we first deal with the constant. And if you look over here in my purple area, the way we would deal with that constant is if we're subtracting 3, then we would add 3, that evaluates to 0, and then we're left with just 2x on the left. And so we would write this out as a number sentence. We would have 2x minus 3, we would add 3, and on the other side, of course, you always have to do to the other side what you've done to the first side to keep your sides equal, so we would add 3 to that side. And then we would simply, these would cancel, and then 5 plus 3 is 8. And then we would solve from there. This first concept is extremely simple. I think actually I've been doing it this way in class as it is. If you look at my blue writing here, all they're showing you is that rather than write that out as a number sentence all in one line, you can write your numbers that you're adding, your constants, below the numbers that you're adding them to. So I can do this in vertical form versus horizontal form. And that's all they're going over in section A of this lesson. So once again, and this is the way I prefer to do it. Okay, so these would cancel, and we would drop down our 2x, and 5 plus 3 would be 8. So that is the only concept they're showing you, is that rather than write it as a horizontal number sentence, you can do this as a vertical problem. Okay, that's section A in this lesson. So in section B, they want to go over negative coefficients. Okay, I just explained that a coefficient is the number that's multiplied by a variable in an algebra problem. So in this problem, 7 is a coefficient, 21 is a constant. In B, they're just adding in the concept of a negative coefficient. So this is why we went over arithmetic with signed numbers, so that you would know that a negative times a negative is a positive. A negative times positive is a negative. A positive times a negative is a negative. And a positive times a positive is positive. And these rules apply also to division. I could say the same thing for division. A negative divided by a negative. I could change these all to division symbols. Negative divided by a negative is a positive. Negative divided by a positive is a negative, and so forth, right? All right, hopefully you know those rules. So all we're showing you here is that when you get x by itself on the left, you divide both sides by that negative coefficient. You have to remember the rules for signed arithmetic. So a negative, divide by a negative, well, these are going to cancel. But on my right-hand side, we have a positive divided by a negative. So which rule is that? Positive divided by a negative? That's going to be a negative answer. So in section B here, all they want you to do is review the rules for signed arithmetic. And remember, when you're solving an algebra problem and you're doing division, remember the rules: negative divided by negative is a positive, and a positive divided by a negative is a negative. Right? So that's, again, really a review of both ideas, what a coefficient is and the rules for signed arithmetic. Now in section C, we're already at section C, look down here and see my properties of equality. In math, they like to go over universal rules, and these are our universal rules that allow us to solve these algebra problems. And really, this is also a review. We already know this. All they're saying is, if you look at the first rule, if A equals B, then A plus C equals B plus C. If 10 equals 10, then 10 plus 2 equals 10 plus 2. Yep, both sides are still the same. They're 12. And you could go down each of these rules and do a similar example and find that if A equals B, then A minus C equals B minus C. All right, and these are the rules that you been following, sometimes without realizing it, when you are solving for x. All right, if let's see, I don't want x in this example. If 9 equals 9, then 9 divided by 3 equals 9 divided by 3, because 3 equals 3. Okay, and that would be rule 4. So in section C, they give you the properties of equality, and they just want you to grasp these universal truths and know that this is actually what you're doing when you're solving for x. In your practice, you're going to solve a couple of two-step problems, and then in one of the practice problems, they're going to ask you which properties of equality did you utilize when you solve them. So look at these 4 rules and say, just ask yourself, was I adding, subtracting, multiplying, or dividing? All right, and they'll want you to state which rule you used when you solved that 2-step problem. Okay, that's all in lesson 84. I'm just gonna, I'll just really quickly work one 2-step problem. Let's see, 75x minus 10 equals, what am I doing here? Let's see, 75x minus 10 equals, 25. I don't know how this is going to come out. All right, so our first step would be, like I told you, we need to take care of our constant right here. So that's the first thing you do in a 2-step problem. Add 10 to both sides. All right, I'm going to do it vertically like they showed us in section B. Minus 10 plus 10 evaluates to 0. I'm left with 75x equals 35. Now I'm going to use, I think it was it property, my third property in the properties of equality. So now I need to deal with my coefficient, 75. I'm going to divide both sides by 75. If I wanted to pull all of these sections together, I should have used a negative coefficient, but and so I have to do that to both sides. Whatever I do to one, I do to the other. My 75s cancel, and I'm left with x equals 35 over 75. Now, guys, you haven't been always reducing your answers. I'm going to start asking that you fully reduce. You can see that 5 goes in both of these. So we're going to divide top and bottom by 5. That's 7 over 15, I think that is, right? Well, you tell me if I'm wrong. All right, and that's fully reduced. So that's a 2-step problem. Take care of your constant first, and then take care of your coefficient and get x all by itself on the left. You can do it. Signing off.